What's up, Shifter? Boop, boop, boop. Bum, 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 bum. Bum, 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 bum. Oh man, why does this not work? Oh, I should get my chat working. It's like, oh god. Oh, OBS. Give me a second. I gotta reset OBS. Piece of shit. What's up, Bob? Bob, we'll get to yours real quick. One second. I gotta reset OBS for some reason. Is Discord not working either? Excuse me? Man. Give me a second. I don't know why. Bum, bum, bum. Oh, I need to reshare this. One sec. See? He's back! Yeah, it's because I'm trying to, like, simultaneously stream to what is it? To TikTok, but Chinese people can't figure out their apps or something, because if I run TikTok and OBS, I think on the same PC, it starts messing with it. It's annoying. Anyways. Okay. I guess no TikTok today. Lag is crazy. Okay, is it better now? Is it? Am I still frozen? I hope not frozen. Am I? I'm not frozen. Yes. Love it. Okay, sweet. Yes. All right, cool. Yeah, you got class real soon. Here, let's do your question, Bob, real quick. Then I'll announce things to all the other people and stuff. There we go. That's working. Good. I'm not frozen. Yay. We love that. Love it. My levels okay on here? Yeah, levels are fine. Okay, cool. It's good. Sweet. Maybe I'll try it later. Yeah, let me do Bob's question because he's got class in very soon. Let's do it. This actually looks like a fun question, Bob.
Looks like a hard one.
Yeah, is it related rates? Is it a related rates question?
What's
What's up,
optimization?
Oh, it's optimization. What's up, Justin?
I'm here to ask my quick question. So I asked it to be simplified. That was a fucking dumb thing.
Yeah,
first
it's
of
already
all. I didn't
simplified.
mean to say simplify.
It's already
I
simplified.
meant to say answer it fully. Like, have it in the large number.
Oh, okay. Yeah, I'll get to that. Here, let me do Bob's question real quick. Then we'll do yours. He's got class real quick, and then we'll do yours.
Bye-bye.
You want? We're gonna play some
Well,
Warzone later.
I'm-
We'll play some Warzone later. Yeah. You want to play with us? Yeah. Jamarcus says his stomach feels terrible. I'm sorry, dude. It's not good. Okay, here we go. Rain gutter is constructed from a metal sheet of width 30 centimeters. Cool. By bending up 1/3 of each sheet on each side by an angle theta. How much should it be chosen so the gutter will carry the maximum amount of water? Okay. So what are we trying to maximize here, Bob?
Fade him.
No, not trying to maximize theta. We're trying to maximize the amount of
Volume.
area in this case, right? Because we assume this thing has like whatever like depth to it, right?
Oh, okay. So,
Yeah. Oh, Jamarcus, yeah, don't eat expired food. It's not good. Don't. Yeah, eat food before it expires. Okay, yeah. So this is it's a trapezoid, right? That's what this is. Okay. By bending up 1/3 of the sheet on each side. Oh, okay, very cool. So this is always going to be 10, right? We know that.
yeah.
The difference is that as we change this thing will change, right? It'll go from here to like here. Okay. So we need to know what the area of a trapezoid is, right? Do you know what the area of a trapezoid is?
It's the height times the average of the top and the bottom.
Very good. Yep. So it's 1/2, right? Base 1 plus base 2 times the height. This is what we're trying to eventually maximize, right? But I need to then make all these variables in terms of what's the maximizing variable, which in this case is theta, right? So one of these bases is already 10. I know that, right? Because this one will always be 10. So the question is what the height is. Okay, cool. We know this is the hypotenuse, right? This will be 10. So then the height is going to be this distance, right? What's that going to be? In terms of theta and in terms of the 10.
Some kind of trig function.
Some kind of trig function? Come on. You know which one this is. Look, hypotenuse theta. What's this?
That's the... So is opposite over hypotenuse.
Yes, good. Which one is
over
that?
hypotenuse.
Yes, so that's sine.
Sine.
Sine. This is, by the way, guys, yeah, you can never forget. You can never forget pre-calc or trig. You can't forget it, dude, because you always have to use it. Yeah. So yeah, cool. Sine of theta is equal to this. This is the opposite, which hypotenuse. Sorry, opposite is h over the hypotenuse, which is 10. Okay, so this ends up equaling 10 sine theta. Okay. All right, cool. So I've gotten rid of this. Nice. Goodbye. So this is 10 sine theta. All right, now we just need B2 in terms of theta. Okay, so B2 is going to be this thing, right?
Yeah.
A little tricky, right? Okay. So, again, draw some more triangles. We love drawing triangles. Okay, so I know that this much of the base, right, Bob? This has to be 10, okay? Just has to match up with that. Okay, so then I just need to know how much is in, like, the wings here on the left and the right. Okay? What are those going to be? So how do I figure out what this is?
Something theta.
It's something with theta. Yes, good.
That would be the... Where would the angle be?
Okay, so we want to know this angle. We want to know what this is, right? This side, okay? Which is the same as if we took this and we projected it down here. Do you see how this part of the triangle is the same part as this?
So, adjacent over cosine.
Good, yes. So yeah, Jamarcus, you were right too. Exactly, Jamarcus, yeah. This is W is equal to 10 cosine of theta, okay? So then, right, this whole thing here, B2, is equal to 2 of these, right? So that's 20 cosine theta. And then it's plus 10 again, right?
Yeah.
Cool. All right. So now we're really cooking, dude. Okay. Because now I have so the 1/2 and the 10 is gonna cancel out. It'll just be a 5. Okay. So that's 5, and then it's 10 plus 10, so that's 20.
20.
plus 20 cosine theta, right? Oop.
Mm-hmm.
Times the sine of theta. All right?
Mm-hmm.
What's up, Falcon? Good to see you, dude. Evening, governor. Okay, cool.
Minimize this.
Now we just got to minimize this. You see how this is easy? Because now this is all just in terms of theta?
Mm-hmm.
Yeah, so this is going to be equal to, what is this, 100 plus 100. So this is 100 sine theta, right? Plus 100 sine theta cosine theta, I think. Right, funny stupid
Yeah.
it? Okay. That's
Yeah.
A. So now I need d80 theta. So that's going to be, what's that? 100 cosine theta.
100 cosine.
And then this is going to be a product rule, right?
Mm-hmm.
So this is 100. So 100 plus 100 cosine squared theta. Right? Derivative of the first times the second plus the derivative of the second. So that's minus derivative of second. So that's going to be, because cosine theta is going to, yeah, so it's minus 100 sine squared theta. Ooh, very cool. And I need this all to equal 0, right?
Mm-hmm.
Okay. I can pull out the hundreds. We don't need the hundreds. Right? Because I could just divide 100 by everything.
Yeah.
And then the other thing I'm going to use here, because I don't like that I have cosine theta, and sine theta. I want to have one trig function. This is a usual thing you want to do in any sort of math. So do you know how to turn like sine squared into cosine squared somehow?
I don't know, probably some secant. Some.
No, another easy one. Sine squared. It's actually too funny. This was actually a meme I was sending today. I sent it to Noise. Where's Noise? Noise, you here, dude? Come in, Noise. Yeah, I love this dude. People may not get this meme. Yeah. Do you know what this meme means? Have you seen this one before?
No.
This one.
No.
You don't know. You don't know what this is?
They're together.
They're together, yes. Because what happens is sine squared of theta plus cosine squared of theta is equal to 1. So it's like, if they're together, they're 1.
I see.
This is some nerdy, like, math ring that, honestly, you know, I don't think anyone would actually get married with these, but I might. I think it'd be kind of cool. I think it's super cool. Anyways, yeah. So that's the identity. That's the identity we got to use. Okay. So knowing that, I know that sine squared of theta is equal to 1 minus cosine squared of theta. You see how I rewrote that? Yeah? Okay.
Yeah.
So now, when I go, like, write all my fancy stuff here, I have cosine theta plus cosine squared of theta, and then it's minus, so it's minus 1 plus cosine squared of theta, right? Is all equal to 0. I think that's right. Okay, cool. All right, so I have 2 cosine squared theta plus cosine of theta minus 1 is equal to 0. What type of equation does this look like?
You put the 1 to the other side?
So if you did, yeah, but then I have this, and that's kind of a mess, right? Jamarcus says, wouldn't setting it to 0 be the minimum? It could be the minimum, or it could be the maximum. What we're going to have to check eventually is actually, like, what the value of it is. But we could also check the second derivative. Setting it equal to 0 just means it's going to be either a min, a max, or, like, some weird discontinuity. It's called a critical point. Yeah. Quadratic. Yes, Jamarcus is right. This is a quadratic, okay? Anytime you see something squared and something not squared and then something that's not even there, that's a quadratic. So this is where you want to say, let u equal to cosine of theta, okay? So this is really 2u squared plus u minus 1 is equal to 0. You see that?
Mm-hmm.
Okay.
Yeah.
Now this is a quadratic you can solve, right? You can see, why not q? I don't know. We could make it q. Why not u? I like u. It's because u substitution happens all the time, Jamarcus. We call it u. Justice for q. Okay. What is this, by the way? This is. I hate doing this when this is this thing, right? It's like what multiplies to -2 but adds up to +1. So that's 2 and -1. I'm gonna do it my lazy way. Okay. 2u squared -1, and then I know it's plus 2u, and then it's -1u. So I can pull a 2u out of this. I can make a u. This is just a -1. 1. Okay, cool. Great. So this is u plus 1 times 2u minus 1 is equal to 0. Cool? All right, we got two solutions here, right? U either equals -1 or u is equal to 1/2. Right?
Mm-hmm. Yeah.
And let's remember that u is equal to cosine of theta. Okay? So I have two answers here. I got to check both of them technically. So cosine of theta is equal to what happens when cosine of theta is equal to -1? What's theta?
That's 0.
No.
Wait. Negative pi?
It's all the way here. It's
Something.
180 degrees. 180 degrees.
Pi?
All the way over. Pi. Very good. Yeah. Okay, good. Yes. So this is theta is equal to pi, or, we'd say 180 degrees, which we can see right now, just right away, right? If this angle equals 180 degrees, right? What is that going to do in your area? Like, you're just going to fold over on itself. Yeah. So that's definitely probably the minimum, right? So we don't need this one. This one's probably wrong. But this one looks promising. So cosine of theta is equal to 1/2. Do you know where that happens?
Pi over 3.
Pi over 3. Good, exactly, yeah. Pi over 6 would be sine, Jamarcus. That would be sine. Yeah, pi over 3. Good. And that's probably the max, right? That probably makes sense. So, yeah. I would say that, yeah. Also, it's the only one that kind of makes sense. Like, theta can only be in between 0 and 90 degrees. So I would say that, yeah, that's the max, and we'll just say it's pi over 3. If you really wanted to test it, I could take the second derivative. I don't really want to. I just assume it's the only one that works. It should be right. Do you have the answer?
The teacher says there's endpoints. How do you know what the endpoints are?
So endpoints here is right. Theta can only be from like 0. Oh, okay, yeah, we do need to check the endpoints. You're so right. Oh, yeah.
0 to 90, I guess.
I would say 0 to 90, right? Because otherwise you're making like a triangle. That don't make no sense. I don't want to do that.
Yeah.
0 also would make no sense, right? Because then this thing has no height, so it has no area. So I guess the only other thing to check is to check 90, right? And in that case, you just have a box. You just have a 10 by 10 box, so that would just be 100. So at 90 degrees, area would equal to 100. You're right. You should check these. I'm skipping ahead because I know that it's probably just going to be this answer. But yes, on your exam, you should check them. And then pi over 3, you just plug into here, which is, what's that? That's 5 times 20 plus 20. And then at cosine of pi over 3, right, 1/2. And then it's all that times sine of pi over 3 is square root of 3 over 2. Okay, so this is already going to be bigger, right? 20 plus 10 is 30, so that's 5 times 30, which is 150 times whatever this is, square root of 3 over 2. So it's technically 75 square root of 3, which is definitely greater than 100. So I think you're good at that point. Yeah, you're good.
Okay. Thank you.
Make sense? Yeah. Awesome, dude. Nice. Good luck with all your stuff. You got a test coming up or anything? You just have class, and you said you had class in like 40 minutes, I guess, right?
Not until a final.
Oh, okay. You did really well in your last calculus exam, right?
No.
Oh, no.
A little below average.
No, dude. You should be above average. Bob, you already know all this shit. Come on, dude.
It was dumb problems.
They were dumb problems. Okay. Well, if you want help before your final, because you only have a final exam left, that's it, and then you're done with this class. Is that what you're saying? Yeah.
Well, like a lot more homework assignments, but.
Oh yeah. But yeah, you just have and you do well on the homework assignments, I assume, right?
I always lose some point. Like.
Oh, okay.
It's dumb.
Okay. Well, if you ever want to bring it to me to be like, here's where I'm losing points, I can try to like suggest things to fix it, I guess. I don't know. But definitely for your final, whenever you have and here, I'll post the screenshot of what we just did, so you can have it. For your final, if you ever get like some sort of like practice final exam or something, I can always kind of guess what problems are going to get asked. I know they're dumb. Dumb questions means they're just really difficult, right? You're just like, oh man, I wasn't expecting it to be that hard. Yeah, yeah. I know all the hard problems they give because I've taught them all. So let me know before your final. Let me help you out.
Okay, thank you.
All right, you're welcome, dude. Jamarcus says, I can't tell if I ate too much or haven't eaten at all, and I don't feel like eating anything. Same. I feel you, dude. Maybe go for a walk or something. That's a good way to like figure out your appetite. You know, sometimes I'm just bored and I just eat things. Not the best. All right, let's see. Ooh-wee. Teacup's got a question. What's this?
I got a question.
Oh yes, you do, Justin. Yeah, wait, Justin. What's your question, dude?
I forgot myself, honestly.
You don't have homework? Do you not have any homework in your classes, dog? Like, what happens?
No, barely. Like, fucking no homework happened.
Do you have a quiz?
week.
You have a quiz you've taken? Like a test?
I think I got a quiz at on Friday, but it's
Do you
not
have
too
a
hard,
practice
so-
for it? Do you have a practice for the quiz?
No,
Do you have
it's gonna be given to us tomorrow, probably.
Do you know a list of
'Cause it's
topics for
on
your
Friday.
quiz?
Nah, they don't tell us that.
Do you go to clown school? What is this? What do you mean? You don't know?
How we do? Honka honka.
Yeah, honka honka. Like you don't know what your quiz is on at all? You just know you have one?
No, like we know like what unit it's gonna be based on. There's
Okay.
two different units.
What's the
it's
unit?
gonna be
What's the
based
unit? What's the unit it's based on? Tell me.
on. Fucking scientific notation and scientific
Fucking-
notation. That's literally it.
Fucking scientific notation. All right, cool. Here, I'll give you a scientific notation question. All right. That's cool.
Keep up.
It's all right. Here,
I'm
I'm
never
gonna ask you this. Write the following in scientific notation.
I can't see the screen right now.
Why not?
But that's
What? Why can't you see the screen?
write the following in scientific notation.
Okay, we can see that at least. Good. Yeah.
Here, let me just. I gotta bench myself.
I know you have an
Sorry.
iPad or something, dude. You can do this.
I don't have an iPad. I'm using an not iPhone, Android. Okay, 0.00800605. There is. It's 0.080. Wait. Yeah, no, it's 0. Wait. 0.0800605. I'm pretty sure.
Yeah. Okay. This is not in scientific notation. First off. This.
Yeah, I know. You're trying to
Did my
to
PC
make me do some like reverse shit right here.
I am. One sec. All my screens just went out.
Shit. Oh, and now your stream is blank. What the hell? Is
Give me
going
a
on with my
second. Give me a
goddamn
second. Give me a second. Give me a second. Is it fine now? Is it back?
phone? Oh yeah, now it's good. It's just bugging for me.
Oh, it's okay. No.
My phone is always,
No,
my
no, no.
phone's always bugging.
No, it bugged on mine too, dude. All my screens just went black for some reason. I was just like, what?
Write the following in scientific notation. 0. No, it's not 0. 0.00.
Do you know what scientific notation is, Justin? Do you know what scientific notation is? It's a good thing to start with.
Something to the something times 10 to the something power.
Good. Yes, good. Yes, good. It's something times something.
Times 10.
Well, times 10 to the something power. Yes, yeah, good. Yeah.
Or it could be something times 10 to something times
And-
something.
well, here,
10 to
there's
something.
There's some rules about whatever this thing is. Whatever this number is here.
Multiplying, subtraction, division, all that stuff. You know?
Yeah, no. We can go with, no, that's a whole other topic. How to multiply and subtract. I'm just saying how to write something in scientific notation. Like, whatever the number
Okay,
is
so
here
hold on, wait a
that you
minute, wait a
have, this has
This
to
would
be
be-
just a single number, and then it can be like whatever here. It can be this, but you can only have one number to the left of the decimal.
0.80605, and then I'm pretty sure you know the decimal. So it'll be 0.80605.
Return of the Lord! It is Return of the Lord. Okay, no. Okay, Justin, first here. I'm gonna show you how to do the first one, then I'm gonna ask you to do another one. Okay. I need
Okay.
this to be some number with just one number to the left of it, of the decimal place, okay? So
Yeah,
this is so
it's
where do I want to put this
0.08
decimal? Where do I want to put this decimal point?
on the left side of the 8.
The right side of the 8. You You want to do this?
Oh yeah, 0. No, it's 8.0605.
There we go. Oh my god. There you go. Yes, good. It's 8.0605.
It has to be a big number. And then in that in scientific notation,
And then it's
pretty
times
sure.
10 to the something, okay?
Hold
And
on.
this, so this, as it was times 10 to the 0, is what we say. When there's
It's
nothing
times,
here,
It's times 10 to the 8th power.
nope. Here's what happens. Okay,
Shit.
I'm gonna tell you guys. All right, here, just listen to me. Listen to me. Okay. Return of the Lurd. Yes, dude, Lurd. Dude, I love this word. It's the weirdest one ever. Okay. Left, up, right,
Right down.
down. Okay. So if you move the decimal point to the left, you need to move this exponent up. If you
Also,
move the decimal
right?
to the right, you need to move this exponent down. Okay,
So-
that's the rule.
And
So-
to the 7th power.
No. Stop. Okay. So
I'm
how
mad
how
confused.
I know, and you're also spastic as fuck. Like, just chill. I love you, Justin, but listen for a second, okay? How many places did I move this decimal, Justin? How many places did I move it?
Oh, 4.
Right, see? 1, 2, 3, 4. Okay.
Oh, 10 to
Which
the 4th
direction did
power.
I move it?
Right.
Move it to the
Which
right.
means it'll go down.
Goes down.
Just 10 to the 3rd power.
10. So what's 4 down from 0?
4 down from 0. 4. Wait. No, 1. No, wait.
What's 4 numbers lower than 0?
-4.
Yes.
Oh, it's my negatives. Oh my god. Oh my
Jesus
gosh. I forgot
Christ.
this, the point.
Yeah.
I forgot that the points, like the 0.00 shit, is that negatives.
Well, don't worry about if it's negatives or not. Don't worry. Don't worry about this or whatnot. Worry about like what happened. So it went from a 0 down 4 makes it -4. I'm glad
Yeah.
Lurd was helpful to you, Jamarcus. Okay, I'm gonna give you another one. Okay, because now it's good. Lurd. Okay, let's do 69,420.69.
Funny.
Funny.
I'm laughing.
Nice.
Okay, how do I write this one in scientific notation?
Lurd. We need a lurd.
Lurd. Yeah, there we go. You guys are gonna remember it. Jamarcus says it saved him on his
Left,
exam.
up, right, down.
Left, up, right, down. Good.
So I'm pretty sure since this is
So where am I moving this decimal to?
moving it to the left 4 places.
Good. See? 1, 2, 3, 4. Okay, cool. And since there was nothing here, this is the same thing as times 10 to the 0. Okay?
Which would be 1.
10 to the 0 is, yeah, just times 1, exactly. Yeah, that's right. That's where. Okay. So I moved it to the right, 4. So my new thing is going to be
you
what?
moved it to the left.
Sorry, I moved it to the left. I moved it to the left 4. So what's this
Which
going to be?
means you'd wait 10 to the 5th power because you're going up.
No, we only moved it up 4, so it's 10 to the 4th.
Oh yeah, 10 to the 4th.
Right?
It's just
1,
the
2,
opposite
3,
of the other
4.
question.
It's exactly it's the opposite of the other one, yeah. So, but what's my final answer? What do I write as my final answer here?
6.942064
Six, nine.
69.
Times.
For some reason, you're 4 9s.
I know they look like 7s or something. Whatever. Times 10 to the what?
10 to the 4th power.
Nice. Good job. Yay.
I'm not ready for this.
Yeah. Well, this is why you should fucking get help from me, dog.
See, I can't do it during sometimes because I'm either playing COD
Okay.
or I'm
Well,
playing COD.
maybe don't play COD. Play COD with me afterwards. You know, we can play tons
Hey,
of
wait, I
COD
need
after.
now I need my COD points because you said ask a question during the stream.
I did say you have to ask the question during stream. I'll get them to you later. Okay, but good. Yeah. Come to the stream.
him.
Come to the stream before your next quiz, please. Like, so I can help you with this. Cause
That's on Friday. That's when the quiz happens. And my
Okay.
quiz is for
ask me during
Thursday.
Thursday's stream or something. I don't know. I'll let you ask during.
I'm not gonna
Thursdays.
ask during Golden Hour. Golden Hour is a freaking podcast. Not
It is,
some
but I'll let you ask
office.
during it. I'll let you ask. You got a quiz coming up. Because Justin, I'm worried, dude. If you actually had this quiz like today, I think you'd fucking fail. Because you had no clue how to do this.
Computer, tell Xbox to turn off.
Yeah, there we go. He's learning. All right. Here, let me help some other people, and then stick around. And if you want to learn more things about scientific notation, and I have time, I'll teach them to you. Okay.
I think my Alexa.
Phone cannot be reached right now.
Alexa
Please check
cannot be reached
network
right now. Okay, let's see. Who do we got?
Computer, shut the fuck up.
Can't say that to her like.
Oh my god.
All right, here. All right, let me help out. Let me help out Teacup, and then if I have more time, I'll help you out. Otherwise, we'll play COD. All right. Cool. All right, Teacup, what's up? Oh, another question 69. Nice, dude. Yeah. Okay.
Me.
Teacup. Do I gotta tag Teacup? I forget if I have to tag Teacup.
Hello.
No, Teacup's here. Cool. The response of an oscillatory is described by this function. Good thing you gave me the page number because this isn't a question. This is just a statement. This is like saying. This is like
it's a question, obviously.
Do you see a question here? I don't see any question mark. Wait, where's the question mark?
I see an equation and I see a number.
Yeah, but they're not asking for anything yet. See, that's a problem. All right, it's okay. I'm glad you gave me the page number so I can find it. Where was it? I have to calculus. What Copilot and Edge, dude? What? Excuse me? There's AI now in Microsoft Edge? That's crazy.
Yeah, you don't know that. It's the Bing chat thing.
Oh, okay. I know Google finally got on their game with it.
Google Bard sucks. It's
Yeah, Bard is pretty fucking terrible.
Bing chat is a dumbed down. It's GPT-4, but it's dumbed down a bit.
Yeah, I heard they removed some stuff, and apparently they got really mad at all the people making the Pixar AI image stuff, and so now they stopped it.
I am happy. I'm happy they got mad at that. I'm gonna show you something. It's crazy.
It is crazy, dude. Well, let's see. Question 69. I'm trying to find this one that you gave. Where is this? Wait, dude. Excuse me. This is not on the right page. Oh, it's 218 of the PDF. Oh yeah, we were doing related rates. Weren't we doing related rates or something? Isn't that what I did with you last time?
So,
Uh-huh. Oh, resonance curves. That's cool. Okay. It's a good type of question. Let's do something a little simpler. It's okay. It's okay. We're gonna do this. Actually, this is very related to what we just did with Bob. Yes, I like these. This is a very good question. Okay, here, we're gonna do this one. I'm gonna grab this one.
Alright.
This is why derivatives are cool, man, because they let you find what the max and the min of stuff are. Like, that's literally what we did back here with Bob's question with the gutter. We were, like, trying to figure out, like, what angle do you want to fold the gutter so that you can carry the most amount of water in it. This is why calculus is cool. You can solve this calculus. It's dope. Mad dope. Okay. Don't worry about that. Okay. So, let's go into how to do this. Okay, so this is a function they have here, right? And they want us to figure out what's the maximum and the minimum values of this function, okay? Do you know how to find that?
It wants the lowest point and the highest point.
Good, yes. And they want it on these bounds from -2 to 2. Exactly, okay. So, one way to do this is to find what we call critical points. Yes, we're going to do your question next. Yeah, okay, so here's how we find critical points. So, critical points are where y prime, basically the derivative of this, is equal to 0, okay? So first thing we're going to want to do here, right, Teacup, is I want to figure out what the derivative of this is. Do you remember how to do the derivative of this?
Let's see, derivative of y. So we want y prime, so that would be...
Yeah, it's good.
4x plus 4x to the 0 plus 0.
Good. Right, I don't need the 0 anymore.
And that just turns into 1.
And you good, that just turns into 1. Good. So, okay, this is equal to y prime. Very good, Teacup. Okay.
And then we have y prime 4 plus 1.
Yeah, so now I want to set this equal to 0. Okay. That's what I want to do.
We're going to do -4.
So, I'm going to say, what, 4x equals -4. So, x equals what?
Yeah. X equals -1.
Good. This is a critical point, is what we're saying. Critical point. Okay. Now,
fast.
I don't know whether this is a max or a min or whatnot, okay? So there are a couple ways you can check this. You can do what's called the second derivative test. I can look at what y double prime is at that point.
You take derivative of the
Good. Yeah, what's the derivative? Yeah, what would y double prime be?
It would be 4x to the 0 plus 1. That means
4x to 0 plus 1 plus 0. Right. This just yeah. So it's just 4. It's just 4 is what it is, right? So this is positive. So there's kind of a cool thing here, and we'll go into it. It's if y prime equals 0 and y double prime is positive, then this is what we call this is a local min. And if y prime is equal to 0 and y double prime is negative, this is what we call a local max. And what this looks like is this ends up looking like something like this, or it ends up looking something like this.
Huh.
Yeah. Because the y double prime has to do with what's called the concavity. So y prime is the slope that deals with, like, you know, how slopey something is. Whether it's increasing or decreasing. Y double prime deals with whether it's a happy face or it's what I call a sad face. Anyways, yeah. Okay, so right off the bat here, because we have a critical point, because y prime is equal to 0, and then at that x equals, well, y double prime is always positive. Do you see how, like, y double prime doesn't depend on x?
Mm-hmm.
That means it's always going to be concave up, which means this is probably going to be a minimum. A way to also check this, however, is to do this. Okay, so we build like a little table. And so what I need to do is I need to plug in, like, here's like my x value, here's like my y of x, and then here's my y prime of x. Okay, and what we do is we plug in our critical point here, which in this case is -1, and then we pick values to the left and to the right of it. So what's a number to the left of -1?
0. No, I mean -2.
-2. Good. 0 would be to the right. Okay. So I can see what the values are, right? If I just plugged it into what our original function is. So if I plug -2 into there, I get 2 times -2 squared. So that's 8. 8 minus 8 is 0 plus 5. That's just 5. Okay. If I plug -1 into here, I get 2 minus 4. So that's -2 plus 5. That's equal to 3. And if I plug 0 into there, I just get 5. Okay, cool. So these are like what the value... This helps you with graphing it, Teacup. Because now you know if you like had a -1 here, you know this should be up at 3. And then at 0, it should be up at 5.
And then at -2, it should be up at 5.
Yeah, do you see how you can already like kind of see the shape of this thing already?
That makes it a parabola.
It's a parabola. It is. It's a wonky parabola. And then you can already see that this critical point here, right, at x equals -1, this has to be a minimum, right? We also knew that from here. This is again, there's multiple ways to do this. Multiple ways you can do this. Okay, if you check the derivative is 0 at -1 because it's a critical point. If I check to the left, right, y prime is equal to this, right? So what happens when x is equal to -2? What happens to the derivative? What is it?
It is when x is equal to -2. It's 5.
The function's equal to 5. What's the derivative equal to?
Oh. No, I got to substitute that.
Mm-hmm.
Okay, so we want to do y prime of x, but we have to plug in the
-2.
the 5 in the negative. Oh yeah, -2.
No, not the 5. You don't have to plug in the 5. Just plug in the -2.
Plug in
This is
-2
x.
to 4x plus 4.
Yes, good. So what do you got?
We have -8.
Good. Plus 4.
-8 plus 4, yeah.
-4, right?
Yeah.
Cool. So that's negative. So what I like to do is I like to draw like a slanty down line like this is what I do because I say it's negative. Something with a negative slope is decreasing, right? So it slopes down. Okay. What happens if I plug in 0 into the derivative? What do I get?
4 times 0 plus 4. So I just be
Positive 4, right?
yeah, just 4.
So here, and I put like an up arrow like this. So this also like kind of helps me graph things because now I can see, oh, it's something like this. 0 is flat, and then it's something like this. That means this must be a local min. That's how that works. You're gonna end up doing more complicated questions, and we'll do one on Friday with you, where like for instance you have multiple critical points. So you have graphs that look probably something like this. So you have critical points like here and here and here. And you have to show that the slope right to the left does like this. To the left and to the right here, like this makes it a max. and then this makes it a min, and then this would also make it another max. Is what it would be. Yeah. This is called optimization. Well, not yeah, it is optimization, I guess. Yeah, it's curve fitting, well, not curve fitting, determining what curves are. Yeah. Cool. Okay, so you got the critical points. So you know this is a local min, and then this was an important thing we went over with Bob is that you have to also check the endpoints. So you have to check what happens on the endpoints of -2 and 2. You already know what happens at -2. It's 5, right? We should check what happens at 2. And so what happens there is that's 4, 8, 16, 21. Wow, okay. That's really big. Okay. So here's the important thing about the critical points. This is whenever it's a local min or local max, that means it could also be what's called technically an absolute min or an absolute max. Like it could be the smallest thing or the biggest thing. The only way to check that though is to see what the actual value is there. Okay? So here, right, we say there's a local min at 3, and I don't have any other critical points. So there's no other places there could be a local min, but I should check the endpoints. Because what could have happened is my function could have looked something like this, like this, for instance. And let's say we were looking from here to here. So technically this would be a local min. But But it's not the lowest point because technically the endpoint here is the lowest. This is like the absolute lowest.
But yeah.
Yeah. So that's why you always check the endpoints, and we did that with Bob. And so that's why we check -2 and 2, 5, 21. These are both bigger than 3, so cool. This is our absolute min. We say this is the absolute min.
Ooh.
And then so what's the absolute maximum then?
Okay, so it'd be. Okay, hold on. This thing I'm looking at on my iPad, it doesn't show the entire board. Where do you find absolute?
So absolute is so it's just where is the function the biggest?
Oh, 2.
And so good at 2. Exactly. Yes, at 2. So it's either going to happen at the endpoint or it's going to happen where the derivative is 0. And there's only one place the derivative was 0 here, and we already determined that was a min. So the only other place that a maximum can happen is at the endpoints. So yeah, so the maximum is 21. Cool. So max equals 21, min is equal to 3, and you are done. Nice. Awesome. Good job, Teacup. Yeah, I'll be around this Saturday. We can definitely do Jackbox this Saturday. I wanted to do it this Saturday. I really did, but I was at that wedding rehearsal, and it just went over by like an extra 2 hours, and I was like, fuck. I can't do it. But otherwise, how else is the tournament going? Or like, I see people doing the dailies all the time, which is good. Maybe we can.
We're doing Jackbox on Saturday too.
Or on Saturday. You want to do it on Saturday or Friday? When do you want to do Jackbox? Either?
Either works, yeah. Whatever works best for you.
What do you think's easier for the? You want to make a quick poll to ask them whether to do it Friday or Saturday?
I feel like Saturday would be better because it's the weekend.
Was Saturday's not the weekend?
No, Saturday is the weekend.
Oh, isn't the weekend? Oh. Okay. I say the weekend starts on like Thursday technically. So.
How does the weekend start on Thursday?
If the weekend can start on Thursday, if you really want it to, it can. Okay, cool. Yeah, we can do it on Friday. Maybe we'll do it before the stream. I'm trying to think of what's a good time for you guys on Friday though. Well, you let me know. Teacup, you ping the students and whatnot, and maybe poll them and try to see what day, like Friday, Saturday, or Sunday, is better. And we can do it. Falconer says Friday.
Yeah, I'll do that.
Okay, yeah. Or maybe I'll do it. I can do it 2 days. I can do like a double header to like make up for it. So.
Oh yeah, let's do a double because we missed the one week.
Because I missed the one last week. Do you guys want to do Friday and Sunday maybe, or Friday and Saturday? Here, have Friday be one of them for sure, and have them vote on whether it to be Saturday or Sunday.
All right.
Okay.
I'll do that after.
Cool. Yeah, you're good. Nice. All right, which Jamarcus? Yeah, which one do you need? Not this one. The other one is the hard one. This is the hard one. So wait, not the Alex going up the stairs. This is the hard one. Okay. Yeah, okay, and this one. Okay, cool. All right, right triangle ABC. Oh, it's a 3-4-5. Love it. Okay. This is AB. And then this is C. And 4, then a 5. Wait, did I make that right? No, I fucked this up. What's up, Ethan? Sorry. A. Dude, what? Wait, how does this work? Oh, A is over here. Why they make this so difficult? Okay. AB is 3. BC is 4. AC is 5. Yes, there we go. Cool. Oh, here, let's do the giveaway real quick. Or here. Yes. Yeah, let's do the giveaway. Office hours. Real quick, and then I'll do your question, Jamarcus. Yeah, because I appreciate you guys coming back. I know, I was out for the last week. So let me do it. Someone's going to win $10. Who's winning $10 today? Who we got? We got Cyber. We got Arian. We got Dark. We got Jamarcus. We got Ethan. Who else? I got Falconer in here for sure. Who else is here? Who else is in the... If you're in the Twitch fam, say hi to get entered. Or just say hi. There you go. I think I got everyone else. Oh, Teacup. I need Teacup in there. Thank you, Teacup. Almost forgot your Teacup. Slimy. Yeah. Your school ends at 5. No more expired bread. I need that bread. No more expired bread. Okay, cool. All right. I think we got everyone. Cyber, Arian, Slimy, Teacup, Falcon, and Dark. Okay, cool. Let's spin it. No expired bread. Let's see if Jamarcus doesn't have to eat expired bread. Where's it going to today? Dude, Nick needs to stop winning these things. Good job, Nick. Good job, Nick. Good job, Nick. I don't know why Nick keeps winning, but yeah. Okay, Nick, I'll get you that. Yeah. I really should make you do the what was it? The brilliant challenge, but I'll let you claim that one. That's okay. Yeah. He is. He's always lurking. He's always lurking in the stream. Ain't no way, dude. He is the spinner wheel champion. Y'all see it. It is random. Like, I do it randomly. I don't know why, but he wins sometimes. He wins a lot of times. I don't know why. It's just like, it likes his name. Okay. Expired bread it is. Okay, right triangle ABC has these sides on it. Square XYZ is inscribed with XY on AC. What? What the hell? Okay. Okay, we got here. X, Y. W on AB. Wait. How does this work? 3, 4, 5. Huh? What's the picture for this one, Jamarcus? I'm just confused. With X and Y on that. Oh, okay. Sorry. I got you. This is W. I got you. And then Z is here. Something like this. Got you, got you, got you, got you. Okay. What is the side length of the square? Ooh, tricky, tricky, tricky. Okay. It's a 3, 4, 5 triangle. Okay. I'm thinking this has to do something with the angles. We're going to do a lot of things with angles here, I'm pretty sure. So if this is 90, right, Jamarcus? And this is... Let's say this is... Okay. This is like... I'm going to call this like the big angle. And I'm going to call this one the small angle, right? Because in the 3, 4, 5, we have the biggest angle, which is the 90. And then I have the one opposite the 3, which is the small one. I think it is similar triangles. Yeah, I think it's how it's going to work. And then the big one, yeah, right? Okay. It's because then this is another 3, 4, 5 triangle, basically. Right? Because it shares a 90, and because if it's a square. So this is also going to have to be the small side. And if this is the small side and this is 90, then this is going to have to be the big side, which means this is going to have to be the small side, which means this is going to have to be the big side, and then this one is 90. Yeah, I think this is how this works, right? Okay. So, yeah, I think we're going to have a bunch of ratios here that are just going to work out. Because all of these triangles here, including the big one, are now similar, right? So, yeah, the only issue is that these sides don't really make sense yet. Okay, so let's come up with sides for these two. Let's call... Because I'm going to label all these segments is what I'm going to do. I want to come up with, like, a naming convention that makes sense. Whatever. Okay. A, B, C, D, E, F. Okay. And then I'm just going to write out a bunch of equations, and then hopefully we'll see something that works out, right? And then we're going to call this thing just side, okay? So I know E plus F plus side has to equal 5, right? C plus D must equal to 3. A plus B must equal to 4. And that's it, right? Yeah. Okay, cool. We're trying to figure out S, all right? 7 variable system of equations. Yeah, but there we have a bunch of other relationships that work out here, which are pretty nice, okay? Because if we look at the big triangle, right, or the big angle, right? So if that's S, I don't think S over... Oh, wait, did I do everything with E? I did. Okay, so yeah. So S over E, so big side over small side, that has to equal 4 over 3. You see how that works? Because this is the angle opposite of the big angle, right? So, sorry, I used S here. Yeah. No, not very bad. Okay, here. Let me call these different angles. One sec. Let me call this right. Yeah, okay. Let me call this large. And I'm going to call this N. Like, not large. Okay, good. Okay. So, yeah, now I'm not reusing angles and stuff. Okay. So, large one over the small one. So that was S over E. That's equal to 4 over 3. Cool. What else do we need? We could also get an equation with this one, right? So B over C is also equal to 4 over 3. And then, what about this one? F over A, no, F over S. F over S is equal to 4 over 3. Okay. And then, one sec, I need a relationship with... So we have E here in S, and we have S. Okay, we're done. We're going to do it with... No, because all we need is S, right? So all I need to do is I need to rewrite E in terms of S, right? Which I can from this equation, right? So here I can say E is... So I can say E is equal to 3/4 S from this one. And then from this one, I can say that F is equal to 4/3 S. I really only needed this one, and this one. If that makes any sense. You don't... I don't need the other variables. I just wrote them out just to kind of see what was happening because it helps out to be like, oh, okay. Yeah, I'm not actually going to solve a 7 system bit of equation here. Yeah, okay. So this is 3/4 S plus 4/3 S plus S equals to 5. Cool. So what is that? I got a common denominator of this thing. Ugh. 9/12 plus 16/12 plus 12/12. S. All this is S. So 25, 37. S times 37/12 is equal to 5. Ew. Okay. So S is equal to 60/37, right? Which is around 2-ish, I guess. What is that? What's on the calculator? It is one of the options. Yeah, 60/37. Yeah, so it should be 1.62. I don't know why this got too big. Yeah, no, it's all good. Yeah, nice. Good job. That's a good one. Yeah, but my general strat here, my head is killing me. Oh no, dude. Let me get you something better than bread. Yeah, okay. Yeah, my general strat here is, you know, draw out some triangles and see where the similar ones are and then write out the equations and see what's the easiest way to get what you want. Okay, yeah, go eat something. Yeah, you're good. All right, here, let's do more questions. I got Ethan and then Cyber. Cyber, I'll do yours next. Let me do Ethan's first, though. Okay, Ethan, what's up? You here? Ethan. I don't hear Ethan. Expired bread eating time, yeah.
Wait, is Ethan even in the chat? Oh, he is.
He's in the... He's muted, though. Ethan.
This entire time I've been watching Big Mouth on Netflix. I recently just got Netflix back after like
nice.
a year.
Big Mouth is good. It's a little adult-ish, I would say.
Well, yeah, but I'm pretty sure they know kids were gonna find us some way or other. So
Yeah.
there's some references saying kids don't do this or that.
Yeah. Yeah. You're supposed to watch with your parents or something. That show is quite funny on how real it
It
gets.
is hilarious. So,
Yeah, I'm like, oh man,
They recently got Megan Thee Stallion instead of it
Yeah.
to be one of the monsters.
Oh, to be what was it? The female hormone monster?
Yeah.
Yeah, they have Maya
Like-
Rudolph is usually the one. She's funny.
now my official personal favorite because she is funny as hell.
Yeah, she's good. It's a good show. Here, let me all right, if Ethan's not here, let me do Cyber's. Cyber, what's up? You want help with this, Cyber? Hi. Yeah, okay, cool. Yes. Okay, cool. Ethan, we'll do yours next. Let me do Cyber's real quick. How do I solve this? How do I solve this one, Cyber? How do you think you solve it? So you did this last year? It's okay. But you have no idea? It's fine. All good. So this is adding fractions. Yeah. The important thing about adding fractions is that they all need to have the same denominator on the bottom. I actually had to do this in Jamarcus's question. That happened here. When we had 3/4 S plus 4/3 S plus S is equal to 5. So here, let's maybe this is probably a good example to show how this worked first. Yeah.
Wait, who won the Office Hours giveaway?
Nick won it.
Nah, I think I should win.
Nick won. It's okay. I'll get you your gift card later today. Let's try to do this
You
one.
should get it right after stream so I can get my COD points and start spending it.
All right. How do you think we
I
do?
need to get my gun. I need to get my gun.
I know. The M4 is apparently super OP right now, so your M4 is good.
I have the M4. It's gold.
Yeah, that's all you need. You just need the M4. Yeah. So we like change the bottom. We do exactly. Yeah, I need to change the bottom of everything here, right? Yeah. So the important thing is here to realize that 1 is the same thing as saying 1 over 1. Okay. But yeah, what I want to do is I want to find what's called a common denominator. So I want to find a number that all of these things like go into. So what number do all these things go into? Sometimes it helps to just start writing factors of things. Yeah, 4, 8, 12. Uh-huh. I mean, we could keep going higher if we wanted to, right? Just keep doing this, but... Mm-hmm. But I want to find a number that all of them go into, right? So what number do all these ones go into? Usually you can stop after a couple. You don't have to keep going. Mm-hmm. 12. Yes, good, yeah. So see how this goes into 12, this goes into 12. 1 eventually will go into 12. I'm not going to write all the numbers out to 12. Yeah, good. Okay. So now I need to make all of these things have 12 on their denominator, okay? And so what I'm going to do is I'm going to multiply the bottom by something that gets this to 12, but whatever I do to the bottom, I also have to do to the top. Okay? So what am I going to do to this to make it have 12 on the bottom? Multiply by 3, good. And what you want to do is you want to multiply the top and the bottom by 3. Because what you're effectively doing here, if you multiply by 3 over 3, you're just multiplying by 1. This is the same thing as multiplying by 1. And so you're not really changing the number, which is great. Yeah, good. So this is 9 over 12. What do we do this one? Times 4. Good. So that one's going to be times 4 over times 4. So that's going to get you 16 over 12. Right? And what about this one? Yeah, times 12. Very good. Yeah. So times 12. Times 12. So that's plus 12 over 12. Good. Okay. So now you can just add these all up. Do you know how to add them up now? Nine, 16, 12. So that's gonna be 9 plus 16, 25. Plus the 12. It's gonna get you good, 37. Yeah, 37. Yeah, and that's why your final answer would be 37 over 12, which would be correct. But this is called an improper fraction because there's a bigger number on the top than the bottom. Sometimes they ask you to write this in what's called like mixed form. Do you know how to do that? It's a good thing to know. It's going to be like something, and then it's going to be like something over 12. Yeah, good, exactly. 3 and 1/12, right? Because 12 times 3 gets you 36, plus 1 gets you the 37. So 37 over 12. Nice. Yeah, there you go. That's good. Nice. Yeah, you're welcome, dude. Yeah. Yeah. I think that was a better one than this. This is easy, because this is just 5s and 8s. Common factor there, I think, just becomes 40. Yeah, but... and it has negative numbers. But I feel like this is a good example as well. Yeah, good job, Cyber.
I got the American bundle.
The American bundle.
What
Oh,
am I getting a text for? No.
the
Sorry,
American
what?
bundle. What's the American bundle?
The butcher set, huh?
Oh, okay. You'll have to show it to me
So-
later. All right, let me do.
Oh, I'm already coming right now. Too late, boss. All right. It's this guy.
Teach me how to make napalm. Yeah, it is easy. Yeah, it's soap and diesel fuel.
So, here are the guns. It's M4, which is America, and then American Bryson.
Oh, it's an American Bryson. Oh, that's fun.
So this has here. I can just go to Gunsmith. This has a VLK Laser 7MW FSS Watchman, a Demo X50 tactical pump, 29.5.
I thought they
nerfed.
nerfed the. Sorry, they nerfed the Lockwood, not the Bryson. They nerfed the Lockwood.
They nerfed the Lockwood.
Yeah, that thing was OP. Okay, here, let me help Ethan with his last question, then I'll play some Warzone with you. Okay?
Is Ethan back?
I think Ethan's back.
Yeah, I'm back.
What's up, Ethan?
Welcome back.
Welcome back,
Yee.
Ethan. I just say welcome back to myself. I've been gone for a while. I'm tired. Need some coffee. Awesome. That's a good question. Let me see. What is the speed of the skateboarder when she reaches the end of the ramp if we ignore the effects of friction and air resistance? Ooh, this is a good one. And then we have this curve thing from a height H collides and sticks to a 5 kilogram block. From what height was it released? Oh, okay. Okay, these are all good ones. Okay, here, let's try and do this one, Ethan. Do you know how to do this one? Is this from your class? Do you guys have this? Is this like a class question you have?
No, it's just that there's nothing really that special going on.
Okay.
So I'm just
Yeah,
picking a random question.
No, I appreciate, you're learning new stuff. This is really cool. You actually kind of know this, but so all right. So they have a, and this is cool. This is where like physics comes in handy, right? Because you're learning about like real world things. You know, here's a guy on a skateboard, and he's bombing down this hill. He's like, woo, you know, and then there's a ramp, right? That's like slightly up. And they want to know what speed you're going. Okay. So whenever I see things with different heights and speeds and whatnot, there's a good strategy, a good technique for solving these. It's conservation of something. Do you know what it is?
Isn't it the conservation of energy?
Good. Yes. Later, I'll teach you about like conservation of momentum. That's another important one. But yeah, conservation of energy comes up a lot, right? Yeah, good. So let's see if we remember. You were so good at explaining it last time, right? How do I use the conservation of energy to solve things?
Don't you use the kinetic energy and the
Good.
potential energy?
Good. Yes. Yeah, you use the kinetic and the potential energy, right? Which we learned, right? That what was it? Kinetic energy is 1/2 mv squared. Do you remember what potential energy is? Say UE usually for it.
No, I forgot.
MGH.
Okay.
Okay. So what I want to do is I want to figure out what the total energy is, which is the kinetic and the potential energy, at one position, and then set that equal to what the total energy will be at another position, and then figure out, you know, what things are. Okay? So
Okay.
let's assume that the skateboarder starts here, like let's say starts at rest. Usually they should have said that, but they didn't. But let's just say it starts at rest, okay? So let's figure out what the energy is here when the skateboarder's at the top versus what the energy is here when the skateboarder is like right about to, you know, launch themselves off of the ramp. Okay?
Uh-huh.
All right. So, let's come up with let's do this. So like what's the kinetic energy here? In the green square.
It's 2 meters, right?
2 meters is the height. That's the height. Let's remember, kinetic energy
Uh-huh.
is equal to 1/2 times the mass. We
Yeah.
don't know the mass. Times the speed. Good. V squared, right? Do we
Uh-huh.
know how fast the person's moving at the top of the ramp if they're just starting off?
He's at 0 right now.
0. Good. Exactly. Yeah, the speed is 0, right? So this whole thing goes away. So there's no kinetic energy there. Okay. All right, let's look at the potential energy, right? So that's going to be the mass, which I don't know. That's m, times g, which is 9.81, and then times the height. Do I know what the height of the skateboarder is here?
It's 2.
Good. Excellent. Okay, cool. All right. So we have our total. Our total here, right, is equal to 0 plus, this is going to be 19.62 times m. That's all that comes out to. All right, Ethan, let's try to figure it out here, okay? So we got
All right.
So we got kinetic energy, right? 1/2 m, and then do we know the velocity that this person's launching off at?
Is it still at rest?
No, because this person's now they're rolling,
It's
they're
unknown.
going down the ramp. It's unknown. Good, it's unknown. I'm gonna leave that as v squared. And here we got the potential energy. What's the potential energy here?
Is it just potential energy is the height, right?
It involves the height. The h is there, yeah. But don't forget the other things, right? What do we have? M
You have the mass
times.
as times 9.81.
Very good, good. Times.
That's the height, which is 1.
Good, there you go. Nice. All right, cool. So now we can write out what that total is. So that total is 1/2 mv squared plus 9.81 times m. All right?
All right.
What's the next step I do? I got 2 total energies at 2 different points.
Basically, you have to make these be the same, right?
Exactly. So whenever they say like make things the same or make them equal, in math that just means set one side equal to the other side. So I'm going to just do this. 19.62, right, is equal to, oh, sorry, and let's not forget that there's an m on this thing as well, right? Is equal to 9.81 m plus 1/2 mv squared. Okay?
Okay.
So, we're trying to solve for this thing, right?
Yes.
Okay. Do we see anything I could like maybe cancel out of all the numbers?
No.
Oh, okay. Do you see how there's an m here, there's an m here, and there's an m here?
Mm-hmm.
So if I have a variable that's in every single thing, I can just cancel it out. Did you know that?
Okay. No.
I'll show you why that is. Well, here let's not do that yet. Let's not do it yet. I'm trying to solve for v here, right? So in algebra, if I'm trying to solve for this variable, what do I have to do to all the other stuff?
Over to the next side.
Good. All right,
Okay.
cool. Let's try to move some stuff the other side. So let's move the thing that's furthest away first, right? Okay. We can move this over, right?
Mm-hmm.
So if I move this over, right, minus 9.81 m minus 9.81 m, that's going to cause this to just be 9.81 m is equal to 1/2 mv squared. Does that make sense?
Yeah.
Yeah? Okay, what am I doing next, Ethan?
I know that.
Hmm?
So
You got it.
I think you want the V2 by itself, right?
We do. Yeah, I want this by itself. See how it's got a bunch of like ugly
So,
stuff like attached to it? We don't like this stuff. Get rid of it.
So I think you gotta divide the m.
Good. So I'm going to divide
on
by
both
m.
sides.
Divide by m. Do you see what happens when I divide both sides by m?
They cancel out.
M's go away. Yeah. The other way to have seen that earlier, Ethan, was that there was an m in every single term here. So if I divide everything here by m and divide everything here by m, these will all go away. But you did it anyways here, which is okay. Okay? So we have 9.81 is equal to 1/2 v squared. What's the next step?
You gotta get the half away,
Good. How do we get the halfway?
you divide it on both sides as well.
Good. So dividing by a half is the same thing as multiplying by 2. Did you know that?
No.
So I could divide by 1/2, right? But the other way to fix this is to multiply both sides by 2. Because you see how the 2 here and the 2 here will cancel?
Huh?
Like 2 times 1/2 will just get you 1, right?
Yeah, I see that.
Good. Okay. So, so let's just do that. Let's multiply both sides by 2, right? So now this is going to become 19.62 again is equal to v squared. All right. I think there's
Square
one
root both sides.
square root both sides. Very good. Very good. Very good, Ethan. Yeah. So now we just do 19.62 to the 0.5. That's the same thing. Square rooting is the same as raising to the 1/2 power. That's another cool thing. So we just get v is equal to 4.43 meters per second, and you're done. Good.
Alright.
Cool. That's a good review question, Ethan. That's a very good review question for you to do. Next time I can teach you stuff about like momentum. I think momentum would be a good topic for you to learn next. Yeah. How was your weekend, Ethan? Sorry, I was gone for the last week. I had to go to this wedding for a whole week basically. But I'm back. I'm back for a while. I'm not traveling anywhere for a while. Probably not till Christmas, honestly.
Okay.
When's your aunt coming into town? Don't I have to ship a controller to your aunt or something?
Yeah, but I still have to submit my report card.
Oh, well, yeah. Well, just you don't have. Yeah, just show me your report card. It's easy, right?
Yeah,
Oh, this is
it will
easy.
be.
Passing all my
Yeah.
classes. Haha.
Yeah, good. Yeah, that's what I want. I want to see you guys passing all
Like
your
literally
classes.
every single one of my classes.
That's good.
I'm
Yeah.
passing.
I'm glad. Yes, my goal is for all
Dr.
you guys to
Gold, I
pass all
really
your classes.
Bundle, but I can't get the Doom bundle
Oh, why not?
because it's 1,800 COD points.
Oh, well, you got to stack up some COD points then.
Hey, Dr.
What's up, Ethan? What's up, man?
Why I can't? Hold on. So, would you why do you have to play Warzone today and not Fortnite?
Because it's Wednesday. Warzone's Wednesday. What if I play Fortnite with you guys on Thursday after Golden Hour? Would that? Oh wait, sorry, I got yoga on Thursday. What if I do it on Friday? Because Friday usually
Nah,
is
that's
Friday's usually yoga, but not sorry. Friday's usually Roblox, but I'd be cool to.
Nah, but I gotta show you Football Fusion. It's literally
Yeah,
NFL, but
yeah.
Roblox.
Okay. Well, here. Is that cool, Ethan? Do you want to play Fortnite on Friday, sorry, instead?
no, it's not cool.
Oh, you can't play it on Friday? Why not? You want to play on Friday?
It's just I want to play like today.
Or you want to play today? Yeah. Well, let me see. I told people I'd play Warzone because it's Wednesday, but maybe I can do both. Let me see what I can do.
How about 2 games of Warzone and 2 games of Fortnite?
Could do that. Yeah, you want to do 2 games of Warzone, 2 games of Fortnite? You guys want to do that?
I'm down to do that, honestly.
Yeah?
Wait, why don't I just buy the game? Why don't I buy the game? Let's switch the game.
Yes, you can do that too. But I have to play 1 game of Warzone at least.
Exactly.
So
I'll take it.
Yo, let's play DMZ so it takes longer.
no, we're not playing DMZ.
No,
Okay.
DMZ is really good for the boss fights, for the
Okay.
haunting,
Oh,
and also really good to get.
Yeah, we can try it out. Okay. All right, cool. Let me end the stream for everyone. All right. Thank you everyone for coming to Office Hours. Had a fun time with all you guys. I know it's been a while. Sorry, I was out for the last week with wedding stuff, but I'm back for the rest of the year. We have our normal streaming schedule. I know a lot of you guys find us on TikTok these days, which is cool. I appreciate all that. So if you ever have any questions in math or science, please post a screenshot in our Discord. The link to our Discord is I don't know. I know the bot keeps saying when our Discord, but yeah, one second. Where's my mouse? Hello, mouse. There we go. Okay, cool. Yeah. So here's the link to our Discord. Join up, and that way you can get all the announcements for when we do streams, and I tutor people. I help you with homework. If you got a test coming up, like, let me help you out. I've taught. I still teach. And I've seen almost all the questions that get asked on these types of, exams and whatnot. So I can help you guys out a lot. And it's all free. This is all free to you guys. This is the nonprofit that we do. If you're wondering about when our schedule is, that's our schedule for the office hour streams. Tomorrow is Golden Hour, which is kind of a more relaxed podcast type of stream where you can just ask whatever. So I tell the students you can ask anything about everything, and I'll talk about it. So if you're wondering about how to get into a career in physics or how to start teaching or any of those things, come by the stream tomorrow. That's going to be I think that's at 3 p.m. tomorrow. Yeah, 3 p.m. Pacific, 5 p.m. Central, 6 p.m. Eastern. And I give out Discord Nitro at that one too. I think I need another person to give Nitro out to because we're missing one boost soon here. Okay, cool. The other thing,
the reason why you're missing one boost, I think I transferred mine by accident.
No, don't transfer them. Don't do it. Anyways, okay. So what we're gonna do now is I'm gonna play some video games with the students. That's what I do. So I teach for a bit, and then we play games with the students. So if you want to hang out and watch us play Warzone, we're gonna do that on the actual gaming stream. Just hang around on Twitch. It'll bring you over. If you're in the Discord, there's a separate gaming channel called Recess. That's our voice chat that we use for that. If you want to play with us, please do. We do Warzone, and I'm also going to do Fortnite. So if you play either of those games, come by and play with us. I give out prizes too if we do well in things. Yeah, Justin, if we win a Warzone, I'll buy you another 1,000 COD points. Cool. So then you can get your Doom bundle. Yeah. Okay, cool. All right. I'll see you guys tomorrow. Peace out.